Alright, so I apologize for all the technical problems. If you saw, I embarrassed myself by having a Windows PC, and for that I'm ashamed, and I will not repent because it's a free PC from my employer. I like free. So if you're in the audience, you can actually, let's see if my pointer's working here. Let me get it turned on. Yeah, I highlighted the link here. So this is actually a web application, so if you're challenged to see and so forth, this will actually put it on your screen and you can follow along as I go. It'll advance the slides for you, but you can pause and go back as needed. So we're going to talk about type level programming. That's not to be confused with type level, the organization. This, I called it that and kind of thought, well, that probably wasn't very smart, but that's fine, we'll leave it. And I'm calling it subspace of Scala, which is not the math vector subspace that you may be thinking, and I'll show you what I mean in a moment. So what I'd like to start with is actually a little bit about myself, not because I like talking about myself, but just give you a little bit of context of who I am and why I would talk about this. Is I've done a lot of Java. I spent actually too many years doing Java. And let's say in 2011 and 12, I started getting bored and started playing with Groovy and tried to build applications with Grails. Very frustrating experience for me. And fortunately, there's a functional programming group in my town that said, hey, you should check out some of these other languages like Scala. I'm like, well, which one do I pick? Well, thankfully Martin Ardursky at that time was offering the first edition of his course on Coursera, so I signed up, and so I'm an alumni of that course, so you can thank him for that, and I'm greatly indebted to him, so I've greatly enjoyed using Scala. And so now I'm actually using it at my current employer, who gives me Windows PCs and to develop applications. They mostly do Windows desktop applications, so they're like, oh, here's a developer, give him a PC. That's what he needs. Sorry, but okay, I'll make it work. And I really like Lyft. This is actually a Lyft application here, and I became a committer recently, and that's kind of where I plug into the community the most right now. And so that's a little bit about me, but the main thing you need to know about that is I come from a lot of Java. So type programming, what do you know about that, Joe? Well, the answer is actually kind of bleak. Actually, not very much, unfortunately. In fact, I've made 0 contributions to Shapeless. Who knows what Shapeless is, right? You probably all came here because you thought you would understand Shapeless. Well, maybe this will help a little bit. And what about cats? Anybody know cats? That's the new one that everybody's talking about, right? I hadn't made any contributions to cats either, although I've contributed a lot of cat memes like crazy, but it hasn't really helped me understand categories. So actually what I'm here to share with you is not my expertise on the subject, but an aha moment I've had, because that's why I'm calling it kind of a 101. It's like when you go to learn computer science as a student, you know nothing about programming. What do they show you? They don't show you, oh, here's what a variable is, and here's what memory is, and registers, and all these things. They say, no, just make it print something. Do something interesting to get you plugged in and doing something. So that's what I start, right? I remember the very first program I wrote, it just printed a letter J for Joe. I was like, well, that's pretty cool. I knew nothing about what was happening. It just worked. So that's what we're going to look at on the topic today. I'm actually not going to use category theory or say anything about category theory. I'm not going to say anything about type theory. Those are great subjects. I'm not saying that there's anything wrong with them, but that's not the topic today. I'm actually just going to get us to start crawling and possibly walking by the end of the day, not getting into the theory and truly understand. This is, again, you start your software by writing a little bit of code and kind of having fun, then you go back and learn all the real theory behind it and get good at it later. So that's kind of the idea that I'm trying to get through here. So what I kind of realized is I was trying to get my own mind around this type programming thing and what are types and all those sorts of things. Because coming from Java, I'm like, well, that's the shape of my data, right? I have a thing that has these things on it, and I have them giving them names, and I shouldn't mix those up because that wouldn't be good. And but what I've really realized with programming Scala is like this game. Now, who remembers Mario 2? I'm dating myself. Yes, there's a lot of hands. That's good because you will understand what I'm getting at here too. So for me, this is a fantastic game. I grew up, loved playing this game. And so this is your normal value programming, right? You come in here and you know what to do. You know to jump and kill these things. You can pick them up and throw things, and you can pick up weeds, and you can climb the vine and all these sorts of things. You can collect the cherry. There's good things there, but there's a lot of stuff that will kill you. You will die, right? That's what happens. And so, but fortunately, they got this cool thing that you can do. If you remember on the first level, you go and like, look at this, a little flask. It's a little flask of type programming, all right? That's what I'm going to call it. Because what you do, you take the flask and you drop it, it becomes a door. And who remembers what happens when you go through the door? Right? The whole world flips over, right? Boom. And you're in what they call subspace. This is what I mean by subspace. Is that there's this sort of weird world, this type programming. It looks kind of the same, but it's not. It's kind of scary looking, actually. I don't know what to do, but there's some really good things for me to get here if I could understand it. right? If I knew how to get to the mushroom, that's going to help me, and if I can get the coins, I can get more lives later, or I can get the cherry, help me get a star to go kill stuff, which is great. So really what I've kind of realized is that really it's kind of this weird world, but it's actually not that different. And if you can pick up some nice stuff here, it could really make you kick some ass in the value world, and that's what you want, is a good running program. So that's kind of where we're going to head today. So let me talk about some really basic stuff. What's the notion of a value, and what happens when we solve? Because what we're trying to tell Scala in the runtime, right, is that I want to have something called num, and I want to be this expression on the right. Evaluate the expression and give it this name so I can use it later. But when does this happen? It's important to know, because it's at runtime, and it's when that line gets hit, right? You can have all these lines, and eventually val num 1, 2, 3. It's going to it might even compile down to 6. Who knows? And it'll become this number 6. But what I'm emphasizing is when it happens, right? Because we've got this other thing that we could use, which is lazy val. And that happens at a different time, right? I declare it, and I say, well, I want a string, and it's going to be these 3 put together. Evaluate that. But when I say it, don't do it yet. Not till I ask for it, right? It happens later. Right? So I've got this name, and I got stuff on the right, and I want to put, reference it by name later. It needs to evaluate something to know what that name is, but I want it to happen later. Don't happen now, right? And eventually when you hit the lazy val, it evaluates, and you can continue to use it just like you would a val. Well, we also know this one, right? Def. This is kind of like lazy val, but even lazier, because it never remembers what it is, right? So every time you call now, in this case, it'll give you this new Java util date, and it'll be like a timestamp, bump, pop, pop, pop. Every time you call it, it evaluates. So you seize it, that line of code, it's like, hey, I don't care what that is. I'm just taking a note. If you ever say now, I know what to do. And I'm going to do it every time. Again, it happens even later, in a sense, than lazy val does, that it continues to happen again and again. But again, in principle, I have something on the left called now, and I want to evaluate the thing on the right and reference it by name. Scary time. Ooh, type. Now, who's done this trick, right? I have my map, and it's a map of this stuff. Who's done this one before? Right, because this is easy, right? This is type def from C days, right? I understand this. This is easy. This is just convenient for me. In my mind, I don't know how it works, but in my mind, it's just sees my map and compile time, just kind of cut paste that thing on top of it, and it's kind of convenient little name. Just like all the other guys I've declared for you so far. But what's interesting, it's still kind of fundamentally the same thing. I have some name, and I want you to evaluate some stuff on the right. But when does this happen? In the compiler. So rather than happening at runtime when it gets first hit, or happening after declaration the first time I access it, or every time I access it, this is something that happens at compile time. But what's interesting is still kind of fundamentally the same thing, right? I'm just taking this evaluation and give it a name and referencing it later. So let's talk about how we would define things with values versus how we define things with types. We're going to use the simplest domain ever so that we can understand it really well. I'm going to make Booleans with values. Not exciting, I know, but that's what we're going to do. And so if I wanted to, let's say there's no true false, I want to make it myself. This is how you would do it, right? I would have a still trait, and I had a couple of case objects for true and false. Pretty straightforward. I can add some operations, so I have my trait Boolean value. I want a not, then I want an or. So I can throw those in there with this definition. And of course, it gets more interesting when you actually start implementing those. So here I have my true value, right? And so his definition of not is always false, right? If you flip true, you get false, or it's always true. I don't care what you or me with, it always comes out to be true. False is similar in that that not flips it over to true. This is super simple, okay, right? No big deal. But the cool thing is we can do this in types. And this is where, when I was playing with this, trying to learn my way from Java into more advanced things in Scala, it's like, well, okay. It's a still trait still. And it turns out the other two guys are still traits too, right? Because a trait is like a type. And I'm going to try this here for you to see kind of what they look like side by side, right? I hope this is not visually destroying your brain in any bad way. This is the best way I could put two snippets of code together. I want you to show you they're the same. It's just instead of case object, it's still trait. And so we can start doing these things, right? So now I got this Boolean type. Just like before, I had vals, or defs, and so forth. Now I have types. I'm doing type programming, so I use a type. I say not. And he is of type, bool type. And I have an or, which takes as a parameter some other one and returns some Boolean type. And again, I want you to step back and look at these side by side. They're the same. right? It's different, looking different, kind of flips the world over, but really you're doing the same stuff. It's just the syntax is a little different, right? Instead of a colon, I use an angle bracket and a colon, right? And instead of lowercase not, I use capital because that's kind of what we do with types because of the whole Java thing. And rather than parentheses, which are round, we use these square brackets and that sort of thing. And so it's still kind of the same shape. If you like math terms, it's isomorphic, right? Just kind of relabel everything as the same thing. And so now if we take a look at the true type, let's actually look at some implementation here. So I've got this type, not, and I'm overriding it and I'm setting to false. Again, we're doing really all the same stuff. I'm just replacing def and val with type. And I'm doing it, so it's all this compile time stuff. And I've got my or, which takes a that, which is some type, which I'm saying is, by God, a Boolean type, a child of it. And when you do an or with me, it's always true. Any questions so far? All right, not too bad? Again, put them side by side. What we see is these are isomorphic, to use the fancy term. And we can see where the really differences are. I'm putting, type instead of val. I'm capitalizing my not, and I'm capitalizing my or, and I'm putting in square brackets. But I'm really doing the same thing, right? And so, like, if you were to write code this way, and like you would normally, and let's say like you were actually doing this with the types, with the values, so with the light blue, you know how to write tests for that, right? You know how to handle that. And what turns out, though, if you want to do the same logic but earlier, meaning at compile time, you just change the syntax around a little bit. So now we can look at false type. Again, it's a little bit more the same song, different verse, right? And obviously not, it always comes out to true, and or, the logic is it's always that. When you or with false, it's always the other value comes out true. And again, you can see these side by side. But I think the gist has been gotten. But how do you test this sort of thing, right? Like if this was values, you know how to test it, right? You may use Scala.This or specs to whatever library you like. You say, well, give me a value, and I say, is it equal to this value? How do you start doing that with types, right? That's kind of a different thing, and don't really know right offhand the way to do that. Well, first off, you compile it, right? This types, this happens at compile time. So all you gotta do is run the compiler. And what you need, though, are some tools like this funny looking stuff here. Implicitly, you got the equal sign with a colon in the middle of it. What's going on? I don't know. I'm not here to tell you what's going on. I'm just showing you, though, that this is equality. Remember, baby steps and crawling, right? We're not going to get into the details. What we want to see is how can I start thinking about this? How do I use it? And then you can go learn what it really is, right? Just like like I compared to earlier in C, right? We're just going to print the name. Don't worry about void and main and int and this pound include, or if you're using Java for the first time, all that ceremony, right? We don't care about the ceremony. We just want to say, hey, this is how you do it. So if you have two types, I want to show that by God they're equal. This will do it. Furthermore, another interesting little syntactic difference is now if I want to say, well, I got this type and there's a type in the type, use pound instead of dot. Again, same stuff, just slightly different syntax. And so this is how I can actually say, well, my true type, dot not, rather pound, is actually equal to false type. So if this compiles, it's all good. If this doesn't compile, then I did something incorrect. So again, it's just, you don't even need any tooling to do this, you just need the compiler. And that's how these sort of things can resolve themselves. A few more examples. Since, by the way, this is advanced track, which is hilarious because I'm from Alabama, in case you haven't figured out my accent yet. So, I mean, Forrest Gump teaching advanced Scala. Let's go. Really, I just took it as a license to put up a lot of code and really overwhelm everyone. So, but again, you see, you can think of it as being the same thing. It's just happening in compile time. I'm referencing with, instead of a dot, I use a pound, and things tend to be capitalized, and still have parameters and all this, and even have this equality thing. But when I was playing around with this, I very quickly went, well, okay, what if I want to show that something doesn't compile? What about my negative test cases? How do I handle that? Well, it turns out that there's actually sorry, my mouse is in the way. There's some pretty cool stuff you can do. So I use the shapeless ill-typed function, macro. This is a macro, so if you were in the last talk, this is certainly like part of that. Just carry on. Is that this compiles only if the string doesn't compile. So if you put garbage in the string, it doesn't compile. So in this case, true type is certainly not false type. And so if I try to compile this code, the macro, it'll run the macro, turn this into code, run the compiler on it. If the compiler fails, it will compile. It's awesome, isn't it? But that's Shapeless for you, right? That's exactly the sort of thing that you do with Shapeless. Actually, if you use Scala, anybody using Scala.This? One thing, they have a similar feature that will do this check at runtime. And so the problem here is, potentially a problem, depends on how you want to work through your application, is that because it fails to compile, you don't get a test report, right? It just blew up, it didn't work. Well, with Scala.This, it'll kind of take a step back. So, well, it'll let all your tests run, and it'll just say, well, the compilation thing over here didn't work the way you expected. I kind of like this one because it's like, well, my positive test cases fail at compile time. I would like my negative test cases to fail at compile time too. But it's all completely up to how you want your test to fail and what you want your test reporting to do when it fails. Is there any questions so far? I love questions and interaction. So yes, question. If you have a typo, if it doesn't compile, it fails. So you might have a crap test. But that's always true of your code, right? So one thing that's funny about the whole test-driven development thing, which I'm a huge fan of, is that when you screw up the test, no one knows what to do. It's like, oh my God, what happened? Because like that wasn't supposed to happen. I don't write bugs there. I write bugs over here in production code. So yes. Again, it goes, but it gives, the test, green, red, whatever iterations that you do, you would write your accident, right? You would have your typo, it would fail. You would go, what you think would fix it, and it still doesn't compile, and you're like, what the hell? And then you go and figure out, oh, well, I screwed up my test code, which is, like I said, very psychologically damaging experience, but it'll happen. Any other questions? Yes, up front.
Just a comment, I think Scala.This actually has a whatever string should compile, but it doesn't have should not compile, or the other way around.
Yeah, I think at some point when I started this whole exploration of my own, this was what I found first, was ill-typed. And I thought that they had that it would not, oh crap, the test would succeed only if the compilation failed. But I thought that's what I had seen, but I still, like I said, I stuck with this one because I was more comfortable with it from working with it previously.
Well, it actually has both. It has should not compile and should not type check.
Oh, it should not compile, it should not type check. So yeah, there you go. Okay, see, it's good that there's actual experts in the room. Excellent. Any other questions? All right, good. We'll keep moving along. And some more examples. So again, it's the same idea. You just put the thing in the string and wrap it up with ill-typed, and it does what you want, right? And again, you have to use the implicitly and all that stuff that would normally, like the idea is if I wrote it straight up, it would not compile, but if I put it inside ill-typed, it'll only pass if it fails. So it's pretty nice to have if you're running. Trying to learn your way through type programming and start playing with it and things like that. Let's see what else. But that's just two types, right? Who cares? It's not very interesting. Just like we don't program with ones and zeros for a reason. Like they didn't even do that in the binary days. They said, no, screw that, octal. Like that's what's up. And so we just got two types, so let's make it more interesting. So here's a lot more code. Again, this is an advanced course, so I'm allowed to show a lot of code. So I'm making a value. This is just like we did earlier. I did some Boolean values, and then I did Boolean types. I'm going to do integer, and then I'm going to actually implement an integer that is a type that can do compile time stuff. So here's my integer. It's just kind of dumb. It's actually, if you're into math, it's Pinot, right? It starts with 0 and recursively defines the successors. But I didn't use all that stuff. I didn't want to scare anybody here, right? We're trying to crawl, right? We're still in diapers. So I have my int val, and I'm going to have a plus, right? I'm just going to add things to them. I'm going to have a real simple operator there. And I have my int 0, which is my base case, as I mentioned for Pinot. And it extends an int val, and my plus is always that, right? If you add me to anything, it's always that, because I'm 0. And int n is int next. I really struggled with the name. I wanted to be succinct. If you work on my team, a running joke is I always give the shortest possible variable names ever, because I'm actually a math geek. As much as I'm staying away from theory, I got a math major when I was in college. But so I tried to pick a name that's nice and short. So stop me if it gets confusing later as we continue to use int in and moving along, but it's int next. So the idea is you pass me the previous one, and I am that next value. And again, I have a plus. So let me show examples of it, and I think then I'll hop back, and I think it makes more sense. So this is how you would use my int, right? So at the top, int 0 is already defined, but int 1 is just the next one after a 0. And int 2 is the next one after 1, and int 3 is the next one after 2, so forth. And then here I use Scala.This. So, your int 0 should equal int 0. That's pretty straightforward, right? You got your should nots and so forth. So that's what my integer looks like. And still to step back, my plus here is, it's always fun to do functional programming, right, without recursion. Like, that's plus, right? It's like, I don't really want to add it up. I'll just let my recursive thing add it for me. It's fantastic. I love it. And so adding something to me is the same as being the successor of adding my previous to that. Is everybody okay with that bottom line? Because we're going to do a lot of this recursion stuff. All right, so moving back forward, so these are examples. So again, 0 plus 1 should equal 1, 1 plus 1 equals 2, and so forth. Very simple stuff. And so moving along, let's do some scary stuff again. Let's get into our scary world of type programming. Excuse me. So this time, again, I don't think I have a slide here which does the zebra thing, but it's really the same, right? It's isomorphic, meaning that you just go and you erase the colons, put angle bracket colons, and so forth. So I can actually have a trait now that's int type as before, but I have a type member rather than a def member, which is for values. Again, I go to this round brackets, I go to square brackets, and all that kind of stuff. But it's exactly the same code. The difference is this makes integers at compile time, which is really neat, maybe. Or maybe it's just kind of pointless. We'll get to that. So here we go. I have my int 0. Again, if I add anything to me, it's just that. Right? It's the same as before. And also the int n, so the next integer, when I add something, I just add my previous and do the next of that. Right? And recursion is magic, and it happens to solve the problem for me, which is fantastic. Questions about this code? Yes, up front.
Yeah, and the previous version was a regular code. I mean, you could probably make it get reversed so it won't go out. Transfer functions, and how do you do that in the type version?
You talking about, tail recursion?
Yeah, suppose you have like, why need to turn 10,000 to 10,000 calls of type.
I'm not suggesting this is a good idea. Again, I'm not the expert in the room. I'm just a guy that kind of stumbled away through and didn't use type theory scary words. But yes, you're right. So again, what I'm going for is, I don't want you to show you ways to do this, because actually, I don't think Miles is here, but it'd be interesting if he was, because I'm sure that they have this in Shapeless, and I'm sure it's much better and well thought out and probably works. But this, on the other hand, what I want to just get you comfortable with is, like, you can do really simple values, you can do really simple types, and have the same logic. It's just, when do I have my logic? I have it at compile time, not at runtime. Good. Other questions before I move on? I mean, I've padded time we will get done early if you don't ask questions, so don't feel shy at all.
Just a comment here. Recursion, in my experience, is not a problem to log the stack or something with compile. It's just a performance issue. You can have a really large recursion there, but eventually the compiler will take years or however long you want it to take.
He said the compiler would take years. Let me take a footnote here. When you do this stuff, they immediately start throwing warnings. What the hell are you doing? It says, trust me, I know what I'm doing. I'm adding flags, leave me alone. Because as somebody tweeted a while back, it was a very good point. It was like, I assume that if my compiler is giving me warnings about features and stuff, I'm doing something really badass, and it's true. And so, yes, so I should have said this earlier. Now your compilation is now the language, the type system is Turing complete. You're not guaranteed the compiler will actually stop. All right, it could go forever. You could do something bad. But the good news is, you write code like that does it all the time at runtime. Why are you so pissed off? This is your desktop. At least it's not your users looking at it, right? This is much better. I'd rather my problems happen now, but I'm kind of still in the thunder of the end. So yes, you're right. It could be just really slow. I mean, but as far as, just do it, and if it's a problem, then optimize it, right? That's generally what you do. Do the simple thing that's easy to understand and that gets the job done. If it's a problem, then go make it faster. My junior developers on my team really struggle with that. They want to make it fast, premature optimization and whatnot. More questions before I digress too much more? No? Okay. Everyone scratches their nose when I ask that question, so it's confusing. So my tests. So that's where I'm at now. And so exactly the same test we had earlier, and exactly, just changing it from values to types. And so I got my types up front. I can do this implicitly equal thing. I can do my ill-typed, and so forth. Again, the syntax is just, kind of foreign looking, and that's what happened to you when you first came into Scala. It turns out there's more syntax. So what's the point, right? Because so far I've just made a bunch of types. It's like, you did integers. And so I should also say that this talk came out of some blog posts I wrote, because I was just really struggling with the huge gulf between me coming from Java and a bunch of dynamically typed languages to like the Haskell-light people, so to speak, and who really understand typing and stuff. So I started just fumbling my way around. And a lot of comments I get on my blog posts, and so far we're about like halfway through the blog series I did. Like, why? What's the point? You've made an integer. Congratulations. I don't care, right? And so let's actually take a little bit of a look at that. So let's make a list of integers. I'm going to simplify the problem. Our list only contains integers, so we're not going to type parameterize that like you would with a real list. This is a crappy list that I'm writing for you. And this is how you would do it, right, in Java or whatever, right? All I can do is just, I've got my list, and I've got values in it that I'll eventually have. And this is going to be a linked list, essentially, or not a linked list, but the whole head tail thing, right? I didn't say a sophisticated YAML. So pretty straightforward, right? You got your basic type, or your trait rather, and you have the nil case, which is an empty list, size 0, and you can make more by having a head and tail. And you know that the size is just one more than that, right? No problems here, right? Pretty straightforward. I think probably this is a rip-off of one of the Odersky course exercises, just basic idea. And let's say, well, I'll have the cons operator that we all love, and also want to have vector addition. Now, what's the catch with vector addition? I have two vectors, right? Size 3 and size 3, they can add. You do A, B, C, and add those guys together. But if you have size 3 and size 4, it's not cool. Like those vectors, they don't add. It's not defined. It's just not okay to do at all. So let's decorate our original trait a little bit more with that stuff. All right, so here's some usage examples of that. I hadn't actually defined it, right? But this is what I want it to look like. I can define this sum, so I'll put 1 and 2 and nil. It's kind of busy because this nil name is kind of long. But, I can take 1 and 2, 3 and 4, 2 vectors of size 2, add them up. And, but then this is about the best we can do, right, is throw some exception and say that's not good. And this is how you would implement that, right? We got this nice little thing from predef called require, rather. And so when I implement my addition on the nil case, the empty list, you give me that integer, that list of integers. And I require that you're me. I'm the only nil, so you better be 0 or not, Or I could have checked size, but this is one way you can do it. If you're, this list simple, lots of code here, right? We're advanced though. So my addition, I require that size is equal to my size, essentially. And I just do like a pattern match, and so I get that one. And if I add up my head and let the tails do the recursive thing on their own, it works, and then my size becomes this. Any questions about how that works? So the thing is, we're validating the size at runtime. But when do we know this size? No one knows? Compile time. Come on, guys. Don't be shy. We certainly know compile time because lists are immutable. And what we're dealing with, so far we're dealing with literals, right? We're not reading I/O or nothing like that. We're not going to talk about any real programming. So here we go. I got my int list. So keep saying it's isomorphic. You could take the old code, decorate it, and you get this pretty much. But we got more stuff this time. So this example is still going to be an int list of values at runtime. The difference is I'm going to do compile time checking of the length for my vector addition, okay? In the previous examples, I took value stuff and made it completely typed stuff. This time I'm going to stay in value world but enhance the code with some type stuff, okay? So these are still values. So what I still have actually, when I look at, for instance, my constructor right here, of the case class, I do have a head, which is a real integer, not a type, and a tail. Okay? Everybody okay with that? All right, so int list, it has some size at compile time, a size which is of type int type, excuse me, the one that we built using recursion and the Pinot type. And I have a nil case, which is an int list of size 0. He's done. That's all there is to know about that. And I got my list implementation that I'm going to, I need the tail size, because in my constructor I need it here. But I am the size 1 greater than tail. I'm the integer next above tail. And so you have to start kind of thinking about, well, what do I need to know this? But you do the same things with values, right? But now you're doing it with types. Don't get freaked out by it, right? It's still the same thing, it's just in square brackets. I go, well, build it backwards maybe is another way to think about it. So I want my case class, my impl. I am an int list of int of something, right? I have to somehow express it. I'm some integer. But you want to tie it to this tail. It's very important, all right? That is where I'm deriving my size from, just like I did in the values, right? My size was 1 plus my tail. I'm doing the same thing. And so I take that in as a parameter up here, and as to my type, and then that becomes the size of the int list here, and then I continue to use it over here in the extends part. Is everybody okay with this? Or got questions? We're doing awesome on time, so don't be shy. I want to make sure everyone's with me. Make sure we're all crawling in our diapers together. All right, excellent. So let's look at the, again, previously I added cons operator, and I added my vector addition to my trait, my base trait. So here we go, base trait. Again, this is my base trait, so I have some size of int type. Now this time I've pulled, I didn't say just int list of int type. This time I'm actually saying, well, give it a name. Yes, kind of like a value, some named thing, just like we've been doing with values all along. And my constructor thingy takes another head and produces a list that's 1 greater than my size, right? When you add an element, well, not add in a mutable sense, but when you prepend an element or append an element, you get this next one that is size 1 greater. And it's pretty straightforward. You just, head and myself. And the definition of vector addition is right here. And what's nice is that the types tell you the constraint now, right? I take a list that is size. But what is size? Oh, well, it's up here, my size. And I'll give you another one with that size. I don't tell you what I'm going to do with them, but you can know something, that the size is going to be the same. You don't call me with a different size one, and I don't give you a different size one. Right? Oh, sorry, questions before I get going. So here's what our usage example looks like. The usage example is exactly the same, except for the bottom, the failure case, right? It doesn't even compile. I can't even put the string in my code any longer. And so what you start to look at with type programming, it puts the onus on the library writer, right? Or the thing that will be invoked. So I get to take advantage of all that nice type checking here without adding any extra work. Right, so that's what's kind of nice about with the type inference we get in Scala, is that you can put all this fancy stuff in there and you just sort of get it. Yes?
Let's say that I tried to compile this instead of wrapping it in a test to succeed.
You just speak a little louder, I don't hear you well.
Yeah, let's say that I actually tried to compile this instead of wrapping it in your negative test. What's the compiler?
I didn't say it was intelligible. It's not the fault of the compiler, I don't think. Again, there's experts in the room here. No, really, because what it is, because the compiler's like, I don't know what the hell you were trying to do, but it doesn't work, is what it tells you, right? And so, I think our compiler authors have gotten fantastic at identifying, like, look, you screwed this up, you probably forgot something here, find the common ones. But when you go in here and you turn on that flag that says, I know what the hell I'm doing, say, okay, this is what happened. So, what do you want to do? Yeah. So, I don't know, it's been a little while since I remember actually looking, because I started just using ill-typed all the time, but off the top of my head, I just remember it's not immediately obvious. It doesn't say like the size is not equal, because that's not really, I mean, that's what you represent with it, but as far as type world is concerned, it just like, it didn't implicitly equal, equal, you know what I mean, kind of thing. Any experts in the room want to give a more intelligent answer? So, no, we got a real question.
What compiler flag are you talking about?
What compile what?
What compiler flag are you talking about that you need to provide?
Can someone answer that question? Because I don't remember. It's one of those that says, hey, if you really mean to do this, just add this flag and we'll shut up. Yeah, I don't remember what it is, because I said, oh, okay, fine, paste that, I don't care. It's not, you know. Right? I mean, who actually thinks about the compiler flags, right? You just copy an SBT project that you found online, put it there. I guess those are important. And apparently if it's 2.9, I need those, and it's 2.10, I need those. 2.11, who knows? Is that a satisfiable punt? Okay.
Higher size, probably. That's my guess.
Something like that, sure. His guess is probably better than mine. I'm not the expert in the room. All right, so other questions before I start jumping along? All right. Okay, int nil. All right, this is where we're at. And so I was actually going to build the implementations up. And so that one's still straightforward as before. I'm certainly an int list of size 0, and I take that, and whatever comes in, it's this. You know, I wonder. I think I should put int 0 there. So there are always potential mistakes in the slides, but now that I look at this, it seems like that probably should have been int 0. Who knows if this compiles? This is HTML. Let's put some zebra stuff going again so we can again see these side by side. And so if I compare again, so really what I'm doing here is like, what does it look like when I do my validation at runtime versus if I do my validation at compile time? And so most everything's the same. You know, now we got this square bracket parameter up here at the plus, and now instead of require, I don't need it. It's type checked. I'm still returning this, and I don't care about size. I only wanted it for validation. You could still implement your size as you wish, but the point of emphasis here is I don't care any longer, because the type inference or the type checking is going to make sure that I get the right value. All right, so more code. This time, this is my implementation list, meaning that this is my head tail guy, right? And so again, I'm doing the same sort of thing, tail size. So give me my tail size. And this is where the fun stuff is in the addition here, the vector addition. So I say, well, whatever that is, it needs to be the same size. Because remember, what's my size? My size is not tail size. That's my tail size. Right? I chose the names to make sense. My size is the next one after tail, right? So that's what I need, is the next one after tail. I hadn't given it another name. You could rename it, right? Just like you do with variables all the time, or values. See, I still got a lot of Java in my mouth. Is that, you do that sort of thing. But you take the thing coming in, and you can do a pattern match, and voila, you're done. What's nice is that it just works, because I said that is by God this size. I don't even have to care anymore. It can't happen if it's not that size. Fun? Questions, comments, concerns so far? So good? All right. All right, this is one of my favorite slides, so pay attention. So this is not the triple question mark thing, right, that you use in Odersky's class, where you just like, well, I don't know what that is, so I just stub it out for now. It returns, type nothing or whatever. So I got my trait now. This is my base trait. I wanted to find a new function. All right, I had vector addition, I had concat, now I've got a third one, which is a mystery, right, some crazy name. But the cool thing is now that I'm using types, I know a little bit of something about my function. Well, I don't know what it does, but I do know this, that I have a size, and the thing coming in has that size, so these maybe not related. And so yeah, okay, sure enough, you're sending me a that, and it's that size, so okay, that makes sense, so pretty good. And it's going to return another int list of size plus that size, my size plus that size. I don't know what it's going to do, but I know a lot about it right now. The nice thing is there's 0 comments in this code, but you know exactly what it returns. There's a lot of information here, right? You know exactly how to call it correctly. You know exactly what you will return. The thing is, you're not really sure, you know, how these values will be related. But you do know a lot. That's very good to know. Anybody want to take a guess at what this one is? Everybody's saying concat. Why are you saying concat? What the hell? See, so there's a handful of folks in the room that already know it just based on the types. Types are very powerful, right? Because, I mean, really, what makes sense here? You got this one and that one. And it comes out that it's the same size. Maybe it shuffles if you're ridiculous. But you know, it probably does. And sure enough, what I was actually doing was 2 pluses, which we're used to seeing with our collections, is a concat, right? Everybody cool with that? See, the types tell you a lot. It's fantastic. It's basically executable documentation, in my opinion. So let's go and start implementing this thing. So I got my nil, and so I'm size 0, and I can concat, and really it's just that. I love nil. Nils are great. So easy to implement, right? So basically, you concat yourself with me, and you are you. Interesting sentences you can say in this talk. Let's go to the more fun one, right? My implementation list. Sorry, again, I've done too much Java. I apologize. I got the head, the tail, the same stuff we're used to up here. But look at this. So it takes that size. The signature's the same. Damn, that was easy. It's just, you know, put it on the end of my tail and let recursion magic happen. But this is the solution, right? If you want to concat that onto me, okay, on the tail, right? So not prepend, but, well, that's it, you know, just my head and my tail put together, and then recursion is magic, and it happens until it hits the base case, all right? Question in the back.
Can you go back to your nil slide?
Yes, sir.
My brain went wrong.
Good, let's fix it.
Aren't they supposed to have the same size? And if so, couldn't you just return nil? I thought they had.
You're thinking of vector addition. My concat is take 2 arbitrary lists and put them together. So you can take nil and then some list of stuff, put it together, and you know, who cares about nil?
Yep.
This is awesome. Everybody else good? Still with me? Love it. And are you okay with this slide now?
I was seeing tail size and that size, and I don't trust it.
Yeah, and again, we're trying to tie together, unless there's type. Is there a typo?
Yeah, I guess you need that with tail plus second part. Yeah.
What's the problem?
So it should be tail plus that dot tail.
No, I don't want to lose the head. See, with recursion, recursion is great because you never actually like do anything. You just say, well, it should be this. You suggest what the solution is, and you tell the computer, go kiss your ass till it comes back with a solution. And that's exactly what it does. It's fantastic. By the way, no one told me about using cuss words. Is that cool? All right, I'm getting thumbs up from the right. Is everybody good with this now? We'll just have to put the little PA on there, you know, when we post it online. Question up. Yeah, actually, I think so. At the end, I'll put a link to the, especially if you're following, I'll put a link to the GitHub, which I hope, so to link to the HTML stuff, which I think has a link to the actual Scala project that I've created all this from. But just get with me later if you want to see it. But yes, it does compile. It was fun. And so here we go. This is what my code looks like. Again, we've done all this stuff, this type gyration. But the people who use my library just use it. Right? There's none of this scary stuff. Actually, I should have changed the color of the background, right? Back to happy value land that we're used to. You know, everything will kill you. But this is the happy place now, right? So, but this is like before, my list of 1, 2, and then I can add 3 to that. I can add my 4, 5, 6 vector addition, and it'll come out to 5, 7, 9. A little bit of syntax around it, right, because of the colons and stuff I chose to use, but it works. And this does type check and the values to come out right. It's pretty nice. Questions about the code?
Okay, so this is actually going back a little bit. You mentioned you could have implemented
tried implementing size in a way that it is an int that is determined in compile time? And is that feasible?
Yeah, you could certainly do that, because the thing I was doing with the values, oh, but you want it at compile time? Oh,
I want it to be, I want it so the size is
okay, let me ask, okay, let's see if I understand your question. For instance, with this one, I want size to be this.
yeah, and so you can definitely get size of that, but I want size to be 5 if the thing has 5 elements so that I can use it, it's a value I can use at runtime.
Okay. So I've thought about that actually. So now I understand your question. So really what you could do back in the int thing that we invented is put the value there.
Gotcha.
Yes, that's how you would do that.
And then you can have the size get the value.
Yeah, you just grab it. That's right.
So the compile time type of the last class is the lower bound of the size of the list. So it's returning that size, like on the south side.
You talking about, this lower bound? I'm not talking, I don't know what lower bound is, man. Hmm?
So for example, if you add a list of the 3 elements and 2 elements, the type that you get is a list of 2 elements, or 3 elements, but that's the type of the other list, right?
No, I've omitted the return type here.
Oh, hold on.
Maybe you could answer
So there's,
Oh, yeah, that's the problem.
does it make, you got it now? So it's a struggle to put this into a slide that you can see and it doesn't confuse you like you just saw, but you good now?
So the type is actually the type of the size of the sound.
Yeah, so the type is back here in the original declaration, which was, and it lists me plus him. Everybody good now? I need to go back forward. Y'all been great. This has been a lot of fun. Good questions. It's really awkward when I just talk at you the whole time. So this is the way I like to run the show. Let's have a retrospective. We're agile, right? Because that's like the thing. Turns out I was wrong. Types are not just the shape of my objects, of my runtime stuff. That's not really what I've got. And actually, so it's kind of like you're expediting computation, right? I'm doing the same computations. I'm just making the compiler do it, right? I'm still checking the size. I'm not just waiting until way damn too late. I'm doing it at compile time. And it guarantees I see the errors instead of my users. Like I said earlier, yeah, you are now Turing complete in your types and it may not stop compiling. Get over it. At least it didn't do it to your users. That's more important than you and your dang convenience. And it kind of like propagates through your code base too, right? So like, I did all this really hard type work in my int list, and it just worked, right? I didn't have to continue tagging types around because our inference does the right thing and gets the stuff that we need. And so it just kind of, it's kind of like everywhere I use this now, correctness just abounds. It's a wonderful thing. And so, are there any questions, comments, or concerns in the back? This, no. This is me playing, right? Right, you're absolutely right. But the thing that happens, and what I hope happens for you folks, is the same thing that happened to me, is that, by the way, if you're following along, go ahead and you can click this and download slides. What has happened for me, though, is now I'm a lot more literate in my code. I don't flip out and say, oh my God, there's 3 square bracket letters, and they're all short. And I don't know what they mean. Now I'm just like, well, at compile time it's passing me things, and we're going to compute on that and return it. So really the question is, do people use shapeless in production? We've got a show of hands using shapeless in production. A couple. Because you guys are here because you're like, I don't know what the hell shapeless is. I need help. So my point is, compile time stuff works. It's just these examples are kind of toyful, right?
So a lot of these tricks, if you are a data user, are used in order to make sure that anybody who's building a client or building a server is fully specified everything they need to specify in order to make it implementation. So it literally is checked at compile time. And there's some trick that I do not understand that the guy who wrote the Nagel does, where he makes the compiler error messages even tell you what you missed.
That's fantastic. That sounds even better than what I did. Yes, up front. And then I'll get the one in the back.
This is a practical use case where we use it as far as tagging
But the CSV file is your data, right?
Yeah, but we specify it for
Oh, I see. Yeah, yeah. You could do something like that, certainly. Probably a macro or something. So that's actually, so if you don't mind, come ask me after we are completely out of time because we started a little late and we ran over. But thank you, you guys have been fantastic. I love talking for you guys. Just bring questions to me. I'll point you to a real expert that can answer them.